name is Lawrence Vita.
And I'm Rachel Hakubi.
And we are a fourth-year BS Ed Science students from Southern Leyte State University Tomas Apos campus.
In this video, we will be presenting the output of our Thesis 2 paper specific to an audiovisual instructional material that we had developed using OBS. This material will serve as an aid in teaching science under modular learning in high school.
To be specific, our study only limits to the development of an audiovisual instructional material, which excludes the actual application of such. Furthermore, this output will only be recommended for future analysis and evaluation.
Good day, class. I hope you are doing great today. To start our virtual discussion, let us all start with our individual prayer first.
Our loving and generous God, we praise and thank you for the bountiful blessings you have given us. Thank you for giving us a mind that can know and a heart that can love. Thank you for giving us the chance to continue learning amidst the pandemic that have caused a lot of changes in our lives. We are sorry for the times we have failed you. We humbly ask for your forgiveness. Father, help us to focus on our studies. When learning becomes difficult, grant us the gifts of courage and enthusiasm. Grant us the courage to use our knowledge in making a difference into the lives of the people around us. All this we pray in your mighty name. Amen.
Alright, good day, class. How are you? Are you doing fine? Have you eaten your meals already? I hope you are all doing great because today will be a great day for our next adventure. Once again, we are still under Quarter 1, the plate tectonics. In our previous video, we tackled Lesson 2, which is the plate boundaries. From that, we've learned the different types of plate boundaries. These are the divergent boundary, convergent boundary, and the transform fault boundary. Before we start, I have 10 shuffle words that I want you all to solve. While doing this, I will be showing a short documentary relevant to our topic for today. While viewing the video, I want you all to list down the things that you will observe, including the different landforms and catastrophic events that will occur. So get your pen and paper and get ready to be mesmerized.
Planet Earth has existed for around 4.5 billion years, much longer than humans have been around, and it's not always looked the way it does now. The Earth is dynamic, constantly changing, and its land masses have been shifting and colliding over millions of years, and have so far left us with the 7 continents we see today. But scientists have recently seen some alarming things, and have become concerned that huge catastrophes are coming. In fact, there have been major volcanic eruptions. Huge cracks have opened up in the Earth's crust overnight before our very eyes, and even the formation of a new ocean is happening right this moment. Throughout time, the continents have been smashed together and pulled apart more than once, like something exploding and imploding over time. It might seem like things are calm depending on where you live, but the Earth is a geologically violent planet. If you have any doubts about it, then you need to look no further than places like Yellowstone National Park in the USA. Covered by beautiful forest and natural geological formations lies a massive supervolcano just waiting to wake up. Yellowstone's supervolcanic crater is so big that you could fit Tokyo, the world's largest city, inside it. If it erupted, it would spew hot volcanic ash for miles across the USA, damaging everything in its path, wiping out crops, and would shut down power plants. There would be mass chaos unlike anything we've witnessed. Damages would be in the billions of dollars, and it's likely the country would never survive. In Hawaii, we have recently witnessed the incredible destruction of an erupting volcano when Kilauea began erupting on April 30th, 2018. Cracks in the earth started to form before the eruption. Lava from a point on the volcano known as Fissure 8 erupted on May 27th, and lava spewed out along the coast and destroyed hundreds of homes. This volcanic eruption has created a new peninsula, and the volcanic eruption could go on for years. There have been massive earthquakes that have caused incredible devastation, such as the March 2011 earthquake in Japan off the Pacific coast of Tohoku, which was a magnitude 9.0 to 9.1 on the Richter scale. It triggered tsunami waves as high as 130 feet and flooded the Fukushima nuclear power plant, causing a catastrophic disaster. These things have been going on since the beginning of time, but the question is, will things get worse? It could be very possible, as nothing is set in stone when it comes to the formation of continents and the violent geological activity of the Earth. The planet Earth is geologically active because its internal heat keeps the outer core and the lithosphere molten, which causes plate movement and volcanic activity. Think of these as huge slabs of rock, miles thick, surfing over the top of the superheated upper zone of the mantle. Inside the Earth, a solid core of iron, spinning in a molten outer core, causes the movement of the magma, which causes the tectonic plates to move in all directions. But those same tectonic plates didn't always exist either. One of the oldest geological places on Earth is called the Great Rift Valley in East Africa. The valley is 3,500 miles long and slices through the land south from Ethiopia to Mozambique. It is 35 million years old and still growing. The area is said to be the cradle of humanity and sparked an explosion of life. The rift began deep below what is now Ethiopia, 2,000 miles below the surface crust, close to the molten outer core of the Earth. Extreme heat and pressure forced a giant bubble of molten rock to the surface, where it swelled and pushed against the Earth's crust, in an area 1,000 miles wide. This tore the land apart and left behind a volcanic wasteland in northeast Africa that overlaps Ethiopia, Djibouti, and Eritrea. It is a desolate and barren wasteland called the Danakil Depression. The Earth's crust here has been so stretched and so mangled by the rifting process that the whole landscape has sunk. There are places down 500 feet below sea level where cooling winds can't get to, which makes the Danakil Depression not only one of the oldest, but it's the hottest place on the surface of the Earth. The Earth is still evolving, and the same plates that have moved around since the beginning are still in very slow motion, and move 1/2 to 4 inches per year. On one hand, it might not seem like much, but over millions of years it adds up to great distances of movement. Recently, geophysicists have discovered something startling about tectonic plates. When they are extreme stress, their movement can accelerate in speed up to 20 times. On the other hand, we're lucky the continents didn't move more than they do now. Imagine movements of 4 inches a month. It's very likely that humans would not be able to survive because the earthquakes would measure more than 15 magnitude on the Richter scale. There would be huge volcanic eruptions and tsunamis would be miles high and would wipe out everything. It's now known that the continent of Africa will split into 2 pieces, and the smaller continent will include present-day Somalia, parts of Ethiopia, and Tanzania, while the bigger one will include everything else. In 2005, a 37-mile crack opened in Ethiopia and continued to split open 30 feet wide in some places over a period of 10 days. Hot molten rock from deep inside is trickling to the surface and creating the split. Underground eruptions will continue until ultimately the Horn of Africa will fall away and a new ocean will form. Parts of the region in Afar are now below sea level, and the ocean is only cut off by a 65-foot block of land in Eritrea. Eventually it will drift apart and the sea will flood in, creating the new ocean. It will pull apart and sink down deeper and deeper until eventually parts of southern Ethiopia and Somalia will drift off, creating a new island, and the Earth will have a smaller Africa. This is not the only time that cracks have opened in the surface of the Earth's crust overnight. In March of 2018, another huge crack opened in Kenya's Rift Valley. In some places, the crack was 50 feet deep and 65 feet across at its widest. Some scientists say this crack is many thousands of years old and was just making its way to the surface. The crack is still growing as the Nubian and Somalia tectonic plates under Africa rearrange themselves and begin to split in two. It's hard to say what the Earth will look like in 100 million years, because the massive tectonic plates seem to alter their course unexpectedly. Some researchers believe that all the continents will eventually all join together again in 250 million years to form yet another supercontinent. But until then, about 50 million years from now, the Atlantic Ocean will be much larger, while the Pacific Ocean will be much smaller. North and South America will have moved farther west, with California moving north. That is, if the San Andreas Fault doesn't push California into the ocean sooner than researchers claim. The western part of Africa will rotate clockwise and crash into Europe, causing the building of massive mountains. The far eastern region of Africa will rotate eastward toward the Arabian Peninsula, and Australia will move farther north into the tropics, and New Zealand will move to the south of Australia. Of course, these are just predictions because, as we mentioned earlier, the movement of the plates is unpredictable. Because a major earthquake or volcano could shift a tectonic plate in any direction. One thing is certain, we are living in exciting times when we can experience the Earth moving beneath our feet and see oceans being born. So what do you predict the Earth will look like in 50 to 100 million years? What new mountain ranges will form, and where will new volcanoes erupt?
Now that we already finished the video, I assume that you already solved the shuffled words, so let's not try to check if you got the correct words. So here are the correct answers. The trench, oceanic ridges, mountain ranges, volcanoes, plate boundary, subduction, earthquake, rift valley, fault, and tsunami. So, congratulations if you got the correct answers. Now, I have another shuffle words again. So, for the final challenge, I want you all to um, guess what would be our topic for today. So, this is the shuffled words for the title of our topic for today. So, I will only give you 20 seconds to guess the title of the topic. So, your timer starts now.
Get ready to the countdown.
Time's up. So I hope you guessed the correct title for our topic, since the title of our topic for today is The Processes and Landforms Along Plate Boundaries. So, in this lesson, we have three lessons that we'll be covering in this topic. So the first one is the lesson 3.1, in which we will identify the geological processes and landforms and how and why they take place and the different types of convergent plate boundaries, which will happen between. So we have three type of convergent plate boundary here. So we have the oceanic continental plates, the two oceanic plates, and the two continental plates. So, that is for the lesson 3.1. So, I have here a picture of the oceanic and continental plates. So as we can see in the picture, we have here the oceanic crust and the continental crust converging to each other. So what could be the possible landforms and catastrophic events that may occur in this type of convergent plate? So the next type of the convergent plate is the ocean and ocean convergent boundary. So as we can see here, we have two oceanic crust converging each other. So as we go along in our discussion, we will identify what could be the possible landforms and catastrophic events that may occur in this type of convergent plate. So the last type of the convergent boundary is the continental plates. So in this picture, we can see the two continental crusts converging each other. So based on the picture that I have shown you, um, I want you all to observe what could be the possible landforms and events that may occur here. Okay, so let's go now for our lesson 3.2, which is the um, divergent boundary. So the different processes and landforms taking place at a divergent plate boundary. So where and why they take place and their effects will be discussed. So I have here a picture of a divergent plate boundary. So as we can see, there are two plates moving away from each other. If converging plate is converging towards each other, the divergent plate is the opposite. The two plates will move away from each other. So I hope you do remember it because we will be using that idea in our discussion later. So let's go to our lesson 3.3, in which it is the last type of the plate boundary, which is the transform fault boundary. The transform fault boundary, also known as the strike slip boundary, will be discussed with the famous San Andreas fault as the main example. So I hope you are familiar with the San Andreas fault. So I have here the picture of the transform fault boundary. As we can see, there are two plates sliding each other. So please do remember the keywords. If converging plates are two plates are converging each other, divergent is the two plates are moving away from each other, and the transform fault boundary is that the two plates are sliding each other. Okay, so let's go now to our discussion proper. So let's start first with the convergent plate boundary. So let's start with the first type, the oceanic to continental plates. Here are the possible events that can happen in this type of plate boundary. These events are the earthquakes, subduction, trench, tsunami, and the volcanic arc. How do these landforms and catastrophic events happen? As we can see here, so I have a picture here. As we can see here, we have the oceanic crust and the continental crust, which are converging to each other. As they converge, the continental crust curves upward on top of the oceanic crust due to its lesser density. It will stay below the continental crust. So we can see here the continental crust, it is above of the oceanic crust. Since the oceanic crust has a greater density, so it will stay below the continental crust. When an oceanic crust converges with the continental crust, a crack between the crust underwater called a trench is formed. So this is the trench. A crack underwater will be formed in between these two crusts. Since oceanic crust has a greater density, it will dive down or subduct under the overriding plate, which is the continental plate, as what I have said earlier. The process is called subduction, which is the process by which a plate dives under a less dense plate. So this subduction occur here. The greater density the crust who has the greater density subduct under the crust who has a lesser density, and that is the continental plate. At the mantle, the leading edge of the subducting plate melts or become fluids, it turns into a hot molten material which we call magma. Due to the heat in the mantle, the magma builds up the pressure that enables it to push the ground above it. So, due to the high temperature here, it enables to push the ground above it, wherein a volcanic activity such as eruption, the ground moves and so the earthquake is felt. So as the magma tend to push this ground here above, so there could be a shaking of the ground and that could be an earthquake. Because subduction continues, a group of volcanoes called a volcanic arc is formed at the surface of the continental crust along the boundary where the two crusts converge. So the movement of the ground may cause disturbances in the ocean. The water may flip or kick upwards to a few meters high, and this is what we call tsunami, since there could be a shaking of the ground and the pushing of the ground in this part, so it can cause a disturbances of the ocean in the ocean. So it may flip or kick the waters upward in a few meters high. That could be a cause of tsunami or the Japanese term for a harbor wave. This event is very dangerous when it moves inland, destroying lives and properties. For a deeper understanding, here is the video clip you need to watch.
Not all boundaries between tectonic plates are divergent where they spread apart from each other, otherwise the Earth would be expanding. Obviously then some are convergent where they collide. What happens? Well, in cases where oceanic plates meet continental plates, the oceanic plates are more dense and the continental plates are less dense. And so therefore the oceanic plates will subduct underneath the continental plates. As the oceanic crust subducts, it heats, and this causes different materials within the crust to separate. The denser material sinks deeper into the mantle. It can ultimately be recycled, being produced as new crust at a mid-ocean ridge, and thus there can be a rock cycle where rock becomes part of oceanic crust, then after subduction becomes magma in the mantle once again, and then later becomes more oceanic crust. The less dense materials from partially molten oceanic crust can rise to the surface as the partially molten components of the ocean crust rise. This igneous material can fill vertical faults and form dikes. It can form sills if it fills in a horizontal fissure. It can be released from the mountain in a volcanic eruption, and there can be a whole chain of these mountains along the line of the subduction, forming a volcanic arc.
Okay, so now let's go to the second type of the convergent plate boundary, which is the oceanic plates. So here are the different events formed in the oceanic converging plate boundary. These are the earthquake, subduction, tsunami, and the volcanic island of arc. So this is shown that oceanic converging plate boundary looks like. So this is shown how a converging of the oceanic plates looks like. So as we can see here, we have two oceanic crust converging towards each other. So as the two oceanic crusts converge, the older and the denser crust will undergo a subduction process. The front part of the subducting plate becomes magma upon reaching the mantle. Then it builds up a pressure due to heat, pushes the crust above it, forming a volcano. This is a continuous process since the plates are moving. So the volcano will move with the plate as well. It becomes extinct when it is no longer above the magma deposited in that mantle area. A new volcano will be formed. This series of volcanoes is called a volcanic island arc since it is surrounded by water. Tsunamis will be formed and earthquakes may happen as well. So, since the plate is moving, these volcanoes here that were formed could be extinct when it will move to a place where there is no deposited magma in that mantle already. So as they tend to move continuously, there's a big possibility that it can be located to a place where there is no magma deposited in that area already. So in that time, the volcano will be extinct. So to further understand the discussion, I have a video here that will give us deep understanding of how oceanic and oceanic plates converge.
This is an example of a convergent boundary where oceanic crust is meeting up with other oceanic crust. When this oceanic crust meets another oceanic crust, one plate is going to be more dense and therefore sink below the less dense plate. As the oceanic crust is forced into the mantle, it begins to heat up. This is going to cause part of the crust to start melting. This less dense magma is going to rise to the surface and create a volcano. Because the volcano is being created on oceanic crust, it's going to be a volcanic island. Where the plate is forced under the other, there will be an ocean trench. During this activity, earthquakes will also be felt.
So that is for the oceanic and oceanic crust. Now let's go to the third type of the convergent plate boundary, which is the continental-to-continental plates. So we have already discussed the three types of the convergent plate boundary, and this would be the last type, the continental-continental plates. In this converging plate, the possible events and landforms that may form are the earthquakes, fault, and mountain ranges. So as we can see here in the picture, we have two continental crusts converging towards each other. Convergent continental crust or plates result in a collision zone, which could cause a shallow earthquake. At that place, a crack called fault is formed. So the crack here, there will be a crack that will be formed here, and that would be called fault. This type of convergence will cause no subduction since the two plates have the same densities. There would be no volcanoes formed, no tsunamis. The convergence will result in a group of high landforms and will call mountain ranges. So, since there is no subduction happen here, so there will be no volcanoes will be formed as well. And the only thing that will be formed here, the landforms that will be formed here, is the mountain ranges. That is due to the collision of the continental crust. So to further understand here, I have a video here. So please to observe.
You see all these mountains and lovely plateaus? Get this, they were formed by something. Something that happens within the Earth's crust, and what happens underneath? The Earth is divided into 4 layers. We'll be focusing on the crust and the mantle, or more specifically, the lithosphere and the asthenosphere. And even more specifically, we'll be talking about how these layers create convergent continental-continental boundaries. The lithosphere is how these tectonic plates go all over the place, and the asthenosphere is kind of the powerhouse that runs the whole operation. Let me explain. 21 miles below the Earth, there are these things called convection currents in the asthenosphere, and the flowing magma is causing the lithospheric plates to slip and slide all over the world. And in our case today, they're colliding head-on. When two continental plates collide, one doesn't just descend into the mantle peacefully like the other types of convergent boundaries. One of the plates is going to go up to create those beautiful mountains we see everywhere, and the other will disappear forever into the abyss that is the mantle. Plateaus kind of ride off the success of the plate that doesn't get submerged. All the convection currents beneath the surface that are causing the tectonic plates to collide is causing magma to try to penetrate the surface When this magma doesn't break the surface, it causes the Earth above it to flatten out and become what it is today.
So to further understanding, we have here a cookie activity that will represent how convergent boundary happen. So I want you all to observe carefully and learn from it. The cookie activity 1, convergent boundary. Get one piece of any cookie you prefer as long as it has a creamy filling. So we have now the cookie. Hold the upper part of the cookie and twist it. After twisting, take the upper part of the cookie and break it into half. Then bring the pieces back at the upper part of the filling. Slowly move the pieces towards each other. As we can see, the creamy filling was compressed to form a mount at the center. The pieces represent the plates, while the creamy filling represents the mountain ranges formed in a convergent plate boundary. Okay, so now let's move forward. So let's go to the second type of the plate boundary, which is the divergent plate boundary. So we already finished the 3 types of the convergent boundary. So what are they? They are the oceanic continental plate boundary, 2 oceanic plate boundary, and 2 continental plate boundary. So now let's move forward to the divergent plate boundary. So divergent boundaries mostly happen under oceans, and the possible events that may happen in this plate boundary are reef valley, oceanic ridges, and seafloor spreading. To understand how these events happen, divergent plate boundary, so I have a picture here. So, divergent plate boundaries mostly happen under oceans. As plates pull away from each other, a vertical space that may extend deep down into the lowest layer of the crust is created. It is a reef valley. The force of separation creates a tension zone, and a shallow earthquake may happen with this plate movement. So we all know that divergent plate boundary is that 2 plates move away from each other. So as the plate divergence is believed to be slow continuous process, as the plates move away, the gap between them increases. While this happens, materials from the mantle may rise up, filling up space. These materials pile up near the tension zone, forming a mountain-like structures called oceanic ridges. But new materials from the mantle may push the old ones. The filled-up space between plates becomes a new seafloor. This process is known as seafloor spreading. So as we can see, the 2 plates move away from each other, creating a tension zone. So since it is a continuous process, so they keep on moving apart or keep moving away from each other. So that could create a continental reef, and as they move apart, um, this space at the center could be filled with water as time goes by. So divergent plate boundary may create reef valleys and mid-ocean ridges. So to furthermore understanding, I have here another cookie activity that will help us to understand how divergent plate boundary occur. So this is just a representation of the divergent plate boundary. So this is our cookie activity number 2. So I want you all to observe and learn from it. Cookie activity 2, divergent boundary. Get another piece of cookie. Apply same instruction in the first cookie activity. Twist the upper part of the cookie, then take it off. Then break it into half. After that, Bring the two pieces back at the upper part of the creamy filling. Then slowly move the pieces away from each other. As we can see, the creamy filling is piling up at the center. This represents the magma or molten materials piling up at the center, which is a continuous process forming reef valleys and mid-ocean ridges. Okay, so we already finished the cookie activity number 2 for the divergent boundary. So now for more videos and more informations, I have another video here. So try to listen carefully and observe and learn from it.
In today's video, we're going to talk about divergent boundaries. There are three types of boundaries when we talk about plate tectonics: divergent, convergent, and transform. So obviously, when we're talking about divergent boundaries, as you can see here, we're talking about things that are moving apart. The first type of divergent boundary that we're going to talk about is a rift valley. So if you look here, this is the Great African Rift Valley, and it moves right through this part of Africa right here. And you can see that Africa is actually being torn into different sections. So they're pulling apart, and it's literally tearing Africa apart. This has happened actually a few places before in the Earth already. If you look down at Madagascar, right down here, it's been torn away from Africa. So these processes keep happening again and again. So if we were to look at these two continental plates, so for a rift valley, we're talking about two continental plates that are moving apart. Now, what would we expect happen if the plates were moving apart? Right here, you're going to be exposing the magma that's down here in the asthenosphere. That magma down here in the asthenosphere is going to start to rise up once they tear far enough apart. So we would expect that we would see some volcanoes starting to happen along this rift valley. And if we look back on this map, you can see that each one of these triangles is just that. It's a volcano forming. You're also going to see that there are some spots where it maybe hasn't torn all the way down to the asthenosphere yet. So right in here, the Earth has pulled away, and you end up with some lakes that are starting to fill in. So here you can see Mount Kilimanjaro, which is a large volcano that's formed when it's torn far enough apart that the magma is starting to rise up. And here you can see a lake that's forming right across that rift valley. The second type of divergent boundary is seafloor spreading. So here you can see we have continental plates and the oceanic plates that are sitting beneath the ocean, obviously. So what's happening is these oceanic plates are being pulled through convection currents that are deep in the asthenosphere. So the asthenosphere rises, moves to the side, and falls. And as it does so, it's dragging these oceanic plates, and so it's moving them apart. Now, we would expect there wouldn't be a gap in the ocean, so when that hot magma rises up here at this gap right here, it's going to form a ridge, and you're going to have some underwater volcanoes as these oceanic plates are pulled to the side. All right, so the question is, where would we find the newest ocean floor being formed? All right, and so what we see is, since there's volcanoes being formed and magma coming out, the new ocean floor would be expected to be found near the center of the seafloor, and the older is going to be out here towards the edges of the ocean. Now we see this happening in specific in the Atlantic Ocean. We have this mid-Atlantic ridge that runs the full length of the Atlantic Ocean. And this is the ridge that Henry Hess discovered when they were first proving that continental drift was happening. So what actually proved continental drift is they found that the ocean floor near the center was new and out here was old. And that proved once again that the ocean floor was spreading and the continents were therefore moving. This is a picture taken by a remote submarine along the mid-Atlantic ridge, and we can see that this underwater volcano is erupting. It's turning the water immediately to steam, but before that steam can ever reach the surface, it's condensing back into liquid water, so we never have any clue about the chaos that's going on underneath us in the Atlantic Ocean. Iceland is actually located right along the mid-Atlantic ridge and is being torn apart. Half of it going with the Eurasian plate, the other half going with the North American plate. This woman right here is actually walking right along the mid-Atlantic ridge. So this part of Iceland is going this way, this part of Iceland is moving this way. And as you would expect, if the island was being torn apart, you would have volcanoes forming.
Okay, so we're already done with the divergent plate boundary. So class, are you still there? We're already in our lesson 3.3, which is the transform fault boundary, which could be the last type of the plate boundary. So I want you all to shake your body and still continue to listen and learn in our adventure today. So for the transform fault boundary, events that may happen in this boundary are faults and earthquakes. So I have a picture here. So transform fault boundary is characterized by plates moving horizontally against each other, producing a crack called fault underground. So as we can see in the picture, we already know that transform fault boundary is the sliding of the two plates towards each other. So as they slide, so a crack form at the center, which is called fault, may occur. The shaking usually ends abruptly. This is why it brings about strong earthquakes. The fault could swallow humans, cars, and buildings. Murky, odorous water from under the ground may spring up from the fault. Most faults do not totally close when the shaking ceases, since the adjoining edges have already moved farther from each other. So this kind of plate boundary is very dangerous as well, as it can swallow humans, cars, and other properties we have. Since it has a fault at the center, this could cause a very dangerous kind of earthquake. I have here a sample picture of the most famous transform fault boundary, and that is the San Andreas Fault. As we can see here, we have a crack at the center. So that is the fault underground, which can cause a very dangerous earthquake. This second picture here is a picture from the NASA. So you can see here a crack as well. This crack is very huge, that it can trigger a very tremendous and very dangerous earthquake. So to further understand, we have the cookie activity number 3. So this will represent a transform fault boundary. So please carefully observe the video. And now we are bound to our last cookie activity. Same instruction. Twist the upper part of the cookie, then break it into half. Bring the pieces back to the upper part of the creamy filling. Then slowly slide the pieces towards each other horizontally. This represents transform fault boundary, which can cause a crack at the center, which is called fault of the ground. This will cause shaking of the ground, which is called an earthquake. So that is how transform fault boundary occur. So I have here another video as well that will help us to understand more how fault boundary occur. Okay, so carefully be keen observer in watching the video.
Transform plate boundaries represent some of the most dangerous geological features in North America, but they can be so deceptively modest in their physical appearance that we build major cities on top of them. Plates slide past each other along transform boundaries, here illustrated by the green lines. While they're rarer than their divergent and convergent cousins, they can be recognized in several locations, typically forming links between longer segments of convergent or divergent boundaries. Let's take a closer look at some of these examples.
The most famous example of a transform plate boundary runs through California and separates the North American plate from the Pacific plate. We'll return to take a closer look at this boundary in the second half of the video.
Some transform boundaries occur almost exclusively in the oceans and are largely hidden from view. For example, the small Scotia plate is separated from the Antarctic and South American plates by transform boundaries along its north and south margins.
The Caribbean plate is about the same size as the Scotia plate, and its northern edge is a transform boundary separating it from the North American plate. Movement along a fault parallel to this boundary resulted in a magnitude 7 earthquake that struck the nation of Haiti in 2010. An estimated 3 million people were affected by the earthquake, which resulted in widespread destruction and many deaths in the capital of Port-au-Prince.
Some transform boundaries are much smaller than these examples. Examination of the ridge system in any ocean basin reveals that it's often offset by short transform boundary segments. Plates move in opposite directions along these segments, making them a source of shallow earthquakes in the ocean basins. But what about transform plate boundaries? What features can we expect to see where these boundaries cut across a continent? Let's take a look at the transform plate boundaries represented by the San Andreas Fault system in California.
The San Andreas Fault system links to oceanic ridge systems from the coastal waters of Oregon in the north to the Gulf of California in the south. The North American continent is actually on 2 plates. Most of it is, as expected, on the North American plate, but there is a sliver of the continent that represents the eastern margin of the Pacific plate.
If we look more closely, we can see that 2 major cities lie adjacent to the transform boundary on opposing plates. Los Angeles can be found west of the boundary on the Pacific plate, while San Francisco is located just east of the fault on the North American plate.
The relative plate motions will slowly move the site of Los Angeles northward along the boundary so that it will eventually be parallel with San Francisco. Given enough time, it will continue its journey northward and may eventually collide with the convergent boundary south of Alaska.
In the meantime, earthquakes of various sizes occur along the San Andreas Fault system, posing a potential danger for any cities nearby. The transform boundary is so unassuming that communities are built right on top of it. Both Los Angeles and San Francisco sprawl outward over the location of the boundary.
Segments of the fault have ruptured to produce 3 major earthquakes in the last 400 years. The most recent event occurred in 1906 and resulted in a fire that destroyed large sections of San Francisco.
The city burned for 3 days, destroying nearly 500 city blocks, leaving 250,000 homeless and killing more than 500 people. The same event today would be disastrous, with potential to kill thousands of people and costing many billions of dollars in damages.
Let's take a closer look at the boundary in the desert of Southern California. The white rectangle represents the field of view for the next image. Zooming in from above on a segment of the fault in the desert, we can make out a linear trace that runs northwest to southeast through the image.
Examining the feature on the ground may reveal a linear fault scarp produced by erosion along the line of the boundary, or may just show a relatively nondescript surface with little to indicate that a major plate boundary is present.
Unlike the depictions in some movies, movement along a transform plate boundary doesn't generate a gap or chasm at Earth's surface. While earthquakes may occur along these boundaries, there are no volcanoes, rift valleys, or mountain ranges characteristic of other boundary types.
Okay, let's see if you can identify the expression of the Alpine Fault, which represents a transform plate boundary in New Zealand.
Can you identify where the fault is located? How about now? We can see it here on the western side of the Southern Alps on the South Island of New Zealand.
And now that we already done with our 3 lessons, which are the convergent plate boundary, divergent plate boundary, and transform fault boundary, let's have now a activity, the application for our discussion. So, in a short bond paper, I want you all to draw the different landforms created along each of the 3 types of plate boundaries. Below each landform, discuss the process behind its formation in a minimum of 2 sentences. So just a minimum of 2 sentences only in a short bond paper. Okay, so for the generalization and abstraction, let's have a recap. So for the summary of our lesson, um, we learned that we have three types of plate boundary, which are the divergent plate boundary, convergent plate boundary, and the transform plate boundary. And for the convergent boundaries, we have three types as well, which are the oceanic to oceanic plate boundary, oceanic continental plate boundary, and the continental to continental plate boundary. So I hope you learned from that. So for the overall summarization, I have a video here that will surely give us a deeper understanding about our lesson, which are the processes and landforms along plate boundaries. So please do watch and carefully observe the video.
Welcome to Moo Math and Science and Plate Boundaries. Some of the most dramatic changes in the Earth's crust, like mountain ranges, new islands, or earthquakes, occur along plate boundaries. There are three types of plate boundaries: divergent boundaries, convergent boundaries, and transform boundaries. Convergent boundaries occur when two plates collide. There are three major types. First is continental to continental. This occurs when two plates of continental crust collide. They buckle and thicken, and this causes mountains to form. Next, you have continental to ocean collisions. When a plate of ocean crust collides with a plate of continental crust, the ocean crust is more thick and subducts or goes underneath the continental crust. The magma from the melted oceanic crust rises to the surface, and this results in volcanoes along the boundary. Ocean to ocean collisions occur when two plates of oceanic crust collide. The older, more dense plate subducts under the younger plate, and as a result, the crust melts and creates an island arc. Next, you have divergent boundaries. This is when two plates move away from each other. The separation allows the asthenosphere to rise towards the surface and partially melt. This melting creates magma, which erupts as lava, and then the lava cools and hardens to create new rock and ocean floor or new continental crust. As the crust and upper part of the asthenosphere cool and become rigid, they form new lithosphere, like mid-ocean ridges. Most of these divergent boundaries are located on the ocean floor. However, rift valleys may also form where the continents are separated by plate movement. And finally, transform boundaries occur where two plates move past each other horizontally. When the plates move next to each other, they do not go along smoothly. Instead, they scrape at each other in a series of sudden slippages of crustal rock, and these can be felt as earthquakes. Unlike the other types of boundaries, transform boundaries generally do not produce magma. The San Andreas Fault in California is a major transform boundary. So there we go, three types of plate boundaries: convergent, divergent, and transform.
Okay, so now that we already finished our three lessons under the processes and landforms along plate boundaries, so I think it's time now for our assessment. Are you all ready? So, for your assessment, we have here a 15-item task. So, we have here the different questions. So, I want you all to answer the following question by choosing the letter of the correct answer. Okay. So for your assignment, in a short pen paper, I want you to search for famous landforms along plate boundaries all over the world. Indicate a picture in landform with its characteristics and basic information. So I think that would be all. That's the end of our discussion. So thank you for joining until the end of our lesson. So I hope you learn. Thank you and goodbye.